Ms. Rofougaran, thank you very much for giving us the opportunity to have you here as a Fireside Chat host. We chatted a little bit yesterday, but I would like to start by asking you to give us a little bit of a background about yourself. When were you born? Where did you go to school? How did your initial interest in technological world started?
Thank you very much for having me, and it's a pleasure to be here and seeing so many Persians and, you know, I'm assuming some non-Persians, but it's always good to see people who are in technology or entrepreneurs, and I'm so glad to be here today. In terms of who am I, where I have come from, so I was born in Isfahan. 1968, so I'm not that young anymore. but so I have a brother who's older than me, who's my partner today. He's been my partner ever since I've come to the U.S., and I tell you a little bit about that later. But and then I have two sisters. One is my brother is the oldest, and I have my sister in between us, who's, she's in the medical field. And my brother is electrical engineer. I'm electrical engineer. My younger sister, who's much younger than me, 6-7 years, she's also electrical engineer.
Let me interrupt just a second. I want to make a point about you being from Isfahan, because in our community, I see a lot of Isfahanis. Although some people have mentioned that, don't mention that people are from Isfahan, because we can't all be from Isfahan and we feel bad. Okay? So, we're not going to do that. We're going to mention the achievements, the origins. So, if you're not from Isfahan, I'm sorry.
Are you from Isfahan?
I am half from Isfahan, yes.
No wonder. And by the way, I don't know if you guys speak Farsi, but if I start speaking Farsi, you'll see I'm from Isfahan. من اصفهانی هستم و لهجه‌ام هنوز همونطور مونده. از وقتی اومدم از ایران بیرون فکر کنم بیشترم اسپانیش لهجه‌ام شده. ولی anyway, so as I was saying, so I was raised in a family who, just like everybody else's family in Iran, cares so much about education. So no matter who you are, what you are, your family always wants you to go to school, even if they know you're not going to be using it or not. But education is really fundamental and really important in Iran, which I think it's great. I think that's why we have so many people who are successful in different fields in US and around the world. And I'm so proud of who we have become and who we have been able to show that, we may be from a country that may have not had such a good name lately, but we are, are strong and we can make difference in the world. So my parents, neither of them were in engineering, or my father didn't even go to university. My mom, even though she was very smart, she didn't get the chance to go, so they were both high school diploma, but they always, I think partially because they didn't do it, they really wanted us to advance. My mom always wanted us to all go get PhD and all that, and from the early on, I remember, and they wanted us to become doctors, by the way, medical doctors.
Like everybody does.
Like everybody does. But I remember my first, when I was in elementary, they always give you that essay and say, what is it that you want to become in the future? And so my mom was helping me write, and of course, it was all about, I'm going to become a doctor, etc. But all of us were good in math, and that was really something that we really liked. My brother, me, it was just something that we were good at and we enjoyed, and no matter what and how much everyone tried to put that, except one of my sisters who really loved the biology and medical school. So I really enjoyed truly solving math problems, and my hobby was sometimes just sitting and doing difficult maths or physics problems, etc. And even though my mom went, and you know how in high school you have to choose whether you want to go medical school or you want to in Iran, so she put me in the field of biology. I used to go to the classes of maths with the other students and attend those, etc. So it happened that it was during the war, Iran-Iraq war, and my brother, the universities were closed, and my brother, if he had stayed in Iran, he would have been drafted and there was no university to go to. And then right before he graduates from high school, he came out, and he came to the US, and he basically started going to school here.
Let me interrupt you. Just one question that we enjoy to ask usually our guests is your concours ranking, but I know you left Iran before you took concours, so we can't.
No, I actually took it.
You did?
I took it, but I didn't even wait for that to come out.
Do you know what your ranking was?
I think it was...
although some people object to that and say we can't all be high ranking, so I'm sorry.
No, I think it was in the first 500 or so, but...
Not too shabby.
But I wasn't even, because as soon as my brother left, I was talking to my parents and I was asking them, I really want to go, I want to go to US because I want to continue, I want to have a path, and they had agreed to. But they said, you have to stay here and you have to do the exam, etc., and then we'll send you because... You
have to do what? I'm sorry.
Take the concours and all that.
You
but
took
we'll
the concours,
you.
but you went to UCLA anyway.
And then I left Iran, and then I ended up coming here.
And you knew you want to do double E in UCLA?
And I did not know that. Okay, I only knew was that I loved math and physics, and so as soon as I came here, my brother came to pick me up from the airport. He picked me up and he took me right away into the lab that he was doing research at UCLA.
And what
so
was
that's
his
how I got
on?
to
What was his
electrical engineering. He was actually doing circuit design and all that.
Circuit design, okay.
So then that's where I got exposed to what engineering was. I mean, honestly, I didn't know much about engineering in Iran. And then, once I got there and I got to learn a little bit about what engineering is, and realizing that, eventually at the end, I have to go to a field that you can do some more practical work, etc. That was the closest to, that was the closest to applications of math and physics, and that's how I ended up.
Let's move forward a little bit. You did your master's and bachelor's and master's in UCLA, and you even continued into the PhD program. But something magical happened during your PhD program, your research. You realized, then you and your brother, that you're coming up with some ideas that it's worth opening a company for. And that was the beginning, the zygote of the company called Innovent, right?
That's right.
Tell us about that. How did that come about?
So I was doing my undergrad, and then immediately I got into my master's, and for my master's I had to work on a thesis. At the same time, my brother, who had finished his master's and had gone to work for a couple of years to get his green card, and so he wanted to come back for his PhD. So he was coming back for his PhD. I was starting my my master's, and so we started looking. My professor was looking at trying to figure out what projects can be done, etc. And there was this DARPA project, which was about integration, doing radio and integration of that in CMOS technology. So I don't know if you guys are familiar or not with the process notes.
Most people are techies here, so they can. I'm sure they can.
So we had an option of choosing different things, but that sounded really interesting because it sounded also impossible.
So the idea was putting an RF circuit at the same time on the same CMOS as a digital circuit.
There were two challenges,
okay.
Right? First of all, at those days, CMOS technology was all 1 micron. I think best case was about 65 nanometer or something that TSMC had. And that was all purely for digital, and some analog were being done, but there was no way that you could imagine you could build a radio at 900 megahertz or above, or even 500 megahertz on that CMOS technology because of all the parasitics, etc. So it's basically didn't sound it's possible to do a radio, not even forget about taking the radio, putting it with digital together on one chip. So building a radio in a low-cost process node in CMOS did not seem to be possible.
As we will see very shortly, this was a huge success story in the business. But what made you so confident? This is a lesson for people. What made you so confident in 1998 that you guys can do this, something that everybody says, oh, it would be good to do, but we can't do that?
You know, usually when you're in university, that's the best time to take the risk. If it works, it works. If it doesn't work, you still get to graduate. It's not that you won't graduate. And we thought that that was very interesting. That was very exciting. A lot of companies were all skeptical. They could not believe this can be done, and that was the right. So you were getting the funding to do it. What's better than that, right?
Where'd you get the funding?
Did we know for sure this is when this is going to become something that changed everything, etc.? I would say no, but we thought we could make something work. Let's put it this way.
You got only $10 million of funding, and in 2 years, just 2 years, you made the company that Broadcom bought it for.
Okay, let me go back a little bit. So the work we did at UCLA, which again we built the radio, and then the next thing was bringing digital to it, because you know, for you guys, you always know digital has a lot of noise. It creates a lot of noise on the substrate. So putting them together was another big challenge. So we were able to put that together, show a prototype, and then you know that created first of all a lot of noise and international recognition, all that, which in a way helped us two things. Realize that this could have huge potential in the industry. Secondly, it put us in a position that we could attract attention, etc., for funding and all that. But then again, you know, it wasn't, you know, it's not like the easiest thing to do. So we decided, that's when I kind of halfway through my PhD decided to drop out. That's when my brother was graduating his PhD at least. And then we came out because of the timing.
You said one PhD is enough for the family.
We said one PhD is enough for the family. It would make my mom happy. So
the draw was so strong there. You were seeing the success happening so much that you thought, you know, 2 years in that company, you can get an equivalent of 2 PhDs.
So I didn't know, yeah. But so we started the company. We still had to go through a lot, you know. Even before that, while we were doing our research, we were doing some sort of consulting with both big and small companies. So that brought some more knowledge of business as well as industry. So when we started, basically, our company, we had some knowledge already as what the startup is and all that. So we started the company. We got some funding. If I remember correctly, we got $2.5 million. And then, you know, our advisor at UCLA, our second advisor was Henry Samueli, who was the founder of Broadcom, which we had classes with. So as soon as they realized we're starting a company, they wanted to come in and invest, so they became investor too. But I think all we raised was really $2.5 million Series A. And in a matter of about a year and a half, we were able to put the first Bluetooth chip together. We showed it, and as soon as we had it, then we had Intel, Qualcomm, Broadcom all wanting to acquire.
But Broadcom acquired you finally for how much?
So again, we started going for our Series B.
I want to get to today's business now, so don't keep us...
Things have changed a lot. You know, it's not 30 years ago. That was 30 years ago. Now semiconductors...
We will discount it. We know how to discount it. It was $500 million.
We closed... yeah, we had an agreement. We signed an agreement for $450 million. But what happened from the time that we signed the agreement to the time that we closed it, because they were a startup too, remember?
I see you have a mind for details.
They went to S&P, and then all of a sudden their sky. So by the time we closed the round, it was almost $800 million. But 6 months later, which was the dot-com era, after 9 months or something, then market crashed. So. Again, it was a great thing for us. I think that was the best thing we did because had we waited longer, it would have been so much more difficult, and we could have had so much problem.
Yeah,
and
500 million, a few million here and there. Who's counting? But you made a great exit, and then part of that exit, you were absorbed into Broadcom.
Yeah, we basically became Broadcom,
yes.
Right? And then that
and you worked at Broadcom for how long?
16 years.
16 years, which compared to the 2 years that you did at Innovent, a very, very long time. And recently, which was about 7 years ago, you started
our second company. Well, true, but within Broadcom, because Broadcom had no wireless, so we basically built the wireless at Broadcom. So they had zero revenue in wireless. By the time we left, we were shipping billions of devices, and revenue was of more than $3 billion per year, etc. So again, it was a startup within a company.
Yes.
We grew it so even though it was a big company, it still felt like we were.
That's what kept you there.
That's what kept us.
And also, you contributed hugely to the income, to the revenues of Broadcom. Almost 50% of the wireless was coming directly from what you did for the company.
True, yeah. And then we got acquired by Avago, which right now they're doing so well, etc. But it's a different kind of philosophy.
So let's move to the present time and actually to the future. What is Movandi about?
Movandi is about Innovent System 2.0.
Okay.
No, so what we're trying to do is basically enabling the next generation of wireless, not just upgrade, you just go, okay, I have 4G, now I make it a little faster. We really are trying to transform this.
What's the frequency we're talking about?
We're talking about 20 gigahertz and above.
20 gigahertz. And the problems with 20 gigahertz when you get that high in the frequency, what are the problems?
The problem is that your wavelength is so short that
millimeters.
You cannot go too far. These walls are going to block it. It's not like Wi-Fi that you're outside and your access point is still.
If it rains, your self-driving car may not be able to connect to the center.
It will degrade it. It depends on again how you make it, all that. But so that's what we're working on, and we have products today. We have built solutions that. Basically address these challenges with millimeter wave. Because right now, the problem with millimeter wave is that there are two problems. First of all, these operators are very old-fashioned, sort of dinosaurs. Very hard to change their mindset and how things are. So
when you say operators, can you explain who are the typical operators? These are Verizons and AT&Ts.
By the way, nothing against them, just they're my partners. But generally speaking, when companies are in a business for such a long time, it gets very hard for them to come up with new, innovative ideas and ways of. Because these kind of new technologies is not just the technology; it's also new business model, new deployment ways of doing stuff, and it becomes very challenging for them to basically get it and come up with all these things quickly. And that's why from day one we've been, even though operators are not our direct customers, we need to still work with ODMs who take our technology, put the box around it. And we've been working directly with the operators on day one from Verizon, AT&T, Telstra, globally, to be able, because they need to learn and they need to. So we've been working with them and bringing ODMs as partners to ship products to them. But yeah, that's usually what happens when the technology is completely new. Unfortunately, it takes longer time, right?
Yeah, you have to educate.
And you have to be very patient and resilient and try to educate and all that. But then once this comes up, then it can exponentially grow. And by the way, even when we did that with Bluetooth initially, and even though there was such hype at that time when we had built the chip initially, and that's why Broadcom, for example, for almost a year after that or so, it became that people started wondering where they can use it, how they can use it. At one point, Broadcom was almost shutting it down. We literally had to keep people working on this on the radar. I had to keep it from our management, but keep it going. And in a matter of a year later or a year and a half later, all of a sudden it just exponentially is, because people figured out once technology is there and some education and the cost starts making sense, then applications are going to be built on it.
So there is some education, and the lesson here is to be patient with the trend of the technology that may take a little bit longer than you think. So you have identified the technical challenges and you're developing solutions for them. Can you give us an inkling of what kind of solutions are you providing? What are the solutions of the short range? The fact that 20 gigahertz technology is very, very short range, that it's susceptible to change of the environment. How do you deal with those? What are the techniques?
So again, for operators to go and try to put G-node base stations that work in millimeter wave, if they have to go and put it on every corner because of short range, the cost of it becomes substantial, makes no sense. So there has to be some ways that you come up with much lower cost and easy to install solution that doesn't take a load truck and many people to go put stuff on the towers. So to extend the range of one G-node B, let's say you have a G-node B or a small cell at the corner of this room, and that is probably good enough to cover this whole, depending on how many antennas you have, etc. It's good enough to cover this whole entire room because there's really no block or anything. But then if you go outside, you won't have much, right? So we've built a technology based on, first of all, we're building the chips, all the millimeter wave, beamforming, antennas, the full front end that works with modem. So we have the modules, but beyond that, we have built a system where you have algorithm, and then we have FPGA, etc., for smart repeaters, which are transparent. Right now they're transparent to the base station. They're so small you can put it on the window. It gets the signal. It's almost like you could say amplifying it, but it's not just amplifying. It could actually redirect it to different locations, and it can still connect to the timing of the G-node B. So it's not just a dumb analog amplifier you put, and then you can put many of them, like 3 of these that are cascaded, do mesh network to ensure that you can cover that whole area outside. And these are small, these are easy to install. And that's basically, I would say, one of the only ways that you can go. So that's what I mean by new deployment kind of ways of doing stuff. And those are all new to some of the customers, so they're starting to actually learn all those kind of stuff.
I have 2 more questions before we turn it to the audience for their questions. And one of them is, can you draw a picture for us what would be the hyper-connected world if everything that you work on succeeds and works beautifully? Then what kind of a world are we looking at in 5 to 10 years from now? What would be the benefits of those?
So I could be sitting here, my avatars could be somewhere in the other side of the world, in the digital, twin. I could be talking, interacting with everybody. So it's all those things that people are talking about with AI, AR, VR, as well as all this sensing, etc. So imagine this way. We talk about AI transforming the world, which truly is. I think AI will be playing a huge deal going forward in how we live, what we live, making the cities smarter. But AI needs data. I mean, AI can't just do things on its own. So it needs data. It needs both data that are available and data that are being generated instantaneously from mobile, from people who are moving, etc. Whether it's autonomous car, whether it's people walking, etc. And there has to be a way for data to actually get to where this, because some things can be done local and will be, AI can be both local, but if you want to make a smart world and something that really people keep giving you all this vision, it also has to be that some of this data get to a center with all data from different locations, and then you can run algorithm and make smart decisions, whether it's for autonomous car or smart city, etc. And there has to be a path that gets the data to these locations.
And you provide
and
that
that's path. Basically, and that has to support instantaneous with no delay, as well as huge amount of data.
There's nothing.
Right.
Yeah. There's speed of light involved. So.
But realistically speaking, this infrastructure and the 5G that people are talking about today won't be sufficient for that. For this kind of future to happen, you're going to have billions and trillions of sensors all around you in the society. In this, look at the Apple Vision that just came out. That's just the proof of
Vision Pro.
Vision Pro. I'm sorry. That's the very first step, or Meta. But these are all coming out with all this sensing, etc. There has to be a path that can basically enable, like a pipe, from devices, from people to locations where AI is being run. And that's
sure
what we're trying to.
You mentioned AI, and I'm sure in your work in reaching the goals, the technical goals that you have plenty for AI to be used and machine learning to be used in the adverse situations. Your antennas, your routing system may have to work differently, and AI will help that. And of course, AI is dear and near to the hearts of many people over here. Can you identify some opportunities that people sitting in the audience can look forward to and maybe get involved, that not everything that your company can do? Can you identify some of the things that people should watch out and maybe cultivate themselves and prepare themselves for?
So I think we keep hearing about AI, and everybody attaches themselves to AI today. It's unbelievable, anyone who's starting something today just throws AI. But I really think at the end of the day, the areas that AI can tremendously, AI will play everywhere, and it's important to be used in everything. But, and then you hear about assistant, this AI assistant and all that. But I really think future is all about medical, healthcare, life sciences, genetics, anything that has to do with health, etc. And AI can make a tremendous difference in those areas. I believe we're behind in life sciences, biology, related to medical health improvement, both in terms of economics of it and affordability, as well as, some of the treatments and inventions that can happen. Just imagine, I really do believe that cancer, again, AI may not be able to come up with the treatment, but there is so much analysis and so much data from patients, so much information that can get captured from the body, from your genes, etc., that needs to be analyzed. And there is no way, even if you throw 1,000 people on it, to sit down and do all this. And I think AI can make a big. I think future is all about that, and those are the fields that.
That's music to the ears of Mo, who presented the startup.
Exactly.
Are there some areas that you can identify which is closer to what you are working on? Antennas, clusters, I don't know, that's your field. So is there any opportunity for people over here for these fertile minds to go after? Some breadcrumbs that your company is not doing and they can start some company. Think about yourselves as 27 years ago when you started your first company.
So
ideas.
Okay. So I mean, what we're doing. We're still a semiconductor company. Core technology, and I think when we started, just to give you an example, when we started our first company, people were saying that if somebody makes a Bluetooth that's $10, it's going to be the best price, right? One of the things about, and the only reason that we were so successful in what we did was that we were able to actually make that Bluetooth less than $1 and fast enough and make it so tiny to be able to go to all these cell phones. And not only that, we didn't stop there. We started integrating, bringing more. We brought Wi-Fi into it, and then we added GPS to it. So one tiny chip that you could literally sell it for even $3 with all these systems, etc. And we were still selling it for more and making good money out of it, good margin. But I think this is the same thing in our field, and that's what we're trying to do. And I think that, whoever starts, the cost and power consumption on these things are very important. And as soon as, so what we're trying to do is bring the cost of this millimeter wave, which is a challenge today, not only because of the chips, but again, being a new technology, the substrate for the packages, the board, all these things, and these will start going down as the volume goes up. But any kind of idea that can be bringing the cost, power consumption of millimeter wave and lower, or generally in cellular, I think that would be the path to go, making better antennas, lower cost antennas.
So if it's the business, dollars is involved. Have that in mind. Well, thank you very much for your thoughts and for feedback on this. Thank you.
Thank you.
We have time for a few questions. Raise your hands and I will pass the microphone. Well, gentleman over there in the back. First down. Oh, no, wait a minute. Wait a minute. He did it first. Keep that microphone, yes.
My name is Amin Eliasia. I'm a part owner of a startup company, Zixopass. I'm really proud of your work, and I'm an electronic engineer as well. I have a question, very important question, health-wise. I studied microwaves long time back, and we found out anything more than anything more than 1 gigahertz is kind of not good for health, brain stuff. So have you done any studies regarding this 20 gigahertz that you're putting out from antennas and what health effects it has?
We have not, but there are governments and some, what do you call it? It's not FCC, but there are entities that's their job, right? So they put restrictions on how much power can get transmitted, whether you're indoor, you're outdoor. FCC is Spectrum, but I think I forgot the name of the consortium that does the, the limitations on that. based on health. But all these are part of, when government basically comes and say, okay, you use this spectrum, they also come up with restrictions saying that, okay, for indoor, and sometimes they spend a lot. I know, for example, in Japan, they've been doing it for the past 4 or 5 years, and now they're finally ready to do it. But having said that, especially when it comes to millimeter wave, one of the challenges is that you lose energy so fast. So usually if there is a problem, it's not really the base stations or the infrastructure devices that are a problem, because by the time they get to you, the energy has gone so low, and that's why your devices have to have such good sensitivity, all that, to even capture it. The challenge is in your devices, exactly. And in that, also how much transmit. It's not the receive side, right? Right, so the transmit, and then how often, how long. So if I'm completely against someone having the phone on their ears, sticking to it for an hour. I don't think it's such a good idea, right? But and then Bluetooth headset, etc., they're so low, and so I think that's what you need to be careful about. But even those, they still have restrictions, and they have to obey those to be able to sell.
Hello. Yes. Hey, Maryam John. Thank you for the talk. I'm a software engineer, so I don't know much about EE. But my name is Kayvon, and I'm the founder of a Smog Shake Network. Something completely different. But my question is, back in the crypto hype, when it happened, there were a network of these antenna networks. One of them was Helium, I believe. Do you guys see a future in such a distributed antenna system that people can host and get rewarded for?
I'm sorry, what was the last word?
Helium is the network that is like a cryptocurrency base. So you purchase an antenna, you get rewarded for the communication that you relay, and so on and so forth.
I don't know how that works, so I can't really comment too much. But generally speaking, distributed antenna is the way to go. I really think that it's a lot better way, especially when it gets to higher frequency. That's mainly the way to go. You really have to be distributing and using mesh and cascading this, rather than trying to have just one node that goes too far and put a huge amount of power and cost into it.
Thank you for the speech. That was really great. We're all proud of this achievement you have. My name is Mani Rezai, and I have a question about the internal feeling you had. At that time, you raised $2.5 million. And after that, were you targeted for really more than 400 million? I mean that, for example, at that time, you were excited about the achievement, or no? You just concentrated on the work. And after you achieved that, you said, wow, that was great. We were so lucky, something like that. I want to know about your internal feeling, at that time, during that 2 years, because it's very interesting for me to know.
We were really focused on trying to get something that works. That was really, not that we didn't care what, how much we can raise later, or we definitely had a lot of aspirations. We wanted to make that company big. We wanted to be able to have a good return for the shareholders, etc. But we were also, a bunch of technologists who came from UCLA, and we wanted to show we can make something happen. So let me tell you what I was, and again, even during those 2 years, it's not that it was a piece of cake. I mean, we still had to negotiate a lot. We were still, it's not like it was our second, or we had a lot of experience. We still had to prove ourselves. And, especially in my case, I was also a young girl coming out to all these VCs who had never seen a woman. I mean, luckily, my brother and I were partners, and it was a big help. But one of the biggest moments of my time and life after that was And this didn't happen after we sold the company for whatever 400 or 500 million. It was when I was at the airport traveling to Greece, because we bought a company in Greece when I was at Broadcom. And then I saw, remember those Motorola Razr phones, the folding ones, the very cool looking ones? So I was at the airport and I saw all these teenagers who are basically showing this phone together and saying, oh, you know, there's Bluetooth in here. And that was our Bluetooth. And even though we were selling in other phones, that was such a hit because Razr became such a big hit phone. And then just seeing that people are bragging about it in front of each other with my chip in it, it was so rewarding. And so it's really something when you see you make something that people are using, and it's really rewarding.
The last question goes to the gentleman in the back. Please say your name and your affiliation.
Sure.
Mani didn't know that.
Thanks so much for the inspiring story. Thanks for coming to Sunnyvale. Hossein Kuhani. I'm a hardware electrical engineer at Amazon, and I'm really excited about the wireless work that we do. And as you rightfully mentioned, AI, especially through cloud, demands infinite amount of connectivity through wireless. But when we think about wireless, like you can increase frequency, you know, like you need to be closer, you decrease it, you know, you have limited bandwidth. So in terms of scaling wireless connectivity in the next few decades, what are the bottlenecks in going up in speed and bandwidth, like exponentially, which we rightfully demand? And are there physics limits in the physics that we have already reached, or is it new material that we need to, you know, design? What are the bottlenecks in your opinion?
So the challenge still is the range, right? But as I mentioned, there are innovations around it that can basically address that. So the material, all those are things that I think over time they're going to improve as this, again, we're going to very high frequency for communication. I'm not talking about radar and sensors, etc. That it's a new kind of era, and it's going to come and it's going to grow. And as that grows, then because so far none of the substrate materials anybody cared about it. So companies haven't really spent too much time to make it better, bring the cost lower. So all those are things that I think will happen no matter what. The main challenge remains with physics. So no matter how much, if I put 30 watts right now here in 20 gigahertz, it can't go beyond that wall, right? If the wall is metal, then forget it. So that's why it requires innovation. So if you're line of sight, I don't think there's any issue. You can go far, you can make your antenna good enough, you can get kilometers even, right? But as soon as something comes in front of it, it's a challenge, and those are the kind of solutions we're working on. And I think, so when you say physics, yeah, there are physics limitations, but that doesn't mean there are not other ways that you go around it. If you just want to think about, okay, we just make things bigger and more power, etc. That's not, so that's why innovations and etc. come into point.
Well, thank you, Ms. Maryam Rofougaran. Thank you very much on behalf of Persian Tech Network, Plug and Play, the Amidi family, and the Persian community. We thank you for taking the time to come here and sharing your insights with us. Thank you.
Thank you very much.
She will be available for a few short questions, but she has a flight to catch. And this is the beginning of the networking time. Have a good time.